Hey kiddos, last video for today. So we have looked at whole number multiplication. And the last thing that I want to review with you before we move on to multiplying with decimals is I'd like to revisit the concept of how we multiply and divide by powers of 10. And so I've started off by putting a whole bunch of powers of 10 on your screen. And some of you might be going, Miss, why do we call them powers of 10? And I would remind you that it's because you can get all of these numbers by multiplying 10 by itself, powers of 10. So just to kind of break that down for you, we're going to review. Let's look at 10. 10 is the same as saying, just 10. 10. 10 times nothing, right? Just 10. One group of 10. There's 1 10 here. There's 1 0 in the answer. Keep that in mind as we keep going. Now, when we move down to 100, 100 is the same as saying 10 groups of 10. Or 10 times 10. And of course, if you think about your base 10 blocks, you're thinking about your rods. When you have 10 rods, you've got a flat. Great. 2 groups of 10 or 2 powers of 10 or 10 to the power of 2. Here I have 1 0, 2 zeros, and in 100 I have 2 zeros, 2 10s, 2 zeros. Now if we keep going down, here I am at 1000. Hopefully you're seeing a pattern here. If I take my 10 times 10, which was 100, and I multiply that by yet another 10, or a third 10, 1, 2, 3 zeros, 10 to the power of 3, or 3 10s, and then 1, 2, 3 zeros. And this pattern continues. I'm going to take that 1000, which is 10 times 10 times 10. And you know what? If I multiply by 10 one more time, it's going to give me one more 0. And that makes sense. 10 1000s is going to give me 10,000. 1, 2, 3, 4 10s and 1, 2, 3, 4 zeros. This pattern continues on forever, guys. And this is a really important thing to understand because this is a skill that we're going to be using when we are multiplying and dividing by decimals. We did look at multiplying and dividing by these powers of 10 in class. Now, I was looking at this pattern here and pointing out the number of zeros that we're adding on, but we didn't call it that in class. When we were doing this skill in class, we started off by calling it adding on zeros, and then we changed our terminology and we started talking about decimal places. And let me tell you what I mean by that. So starting off with the number 10, like I did at the front here. So here is 10. There is always a decimal in numbers. Even whole numbers where you don't see the decimal. This 10 right here has a decimal. Where is it? Hopefully you guys are all pointing at right here. There is a decimal after the whole number. If there are no digits in the decimal place value spots, then we often don't show the decimal, but that does not mean that the decimal does not exist. It is always there. So multiplying by powers of 10, sometimes you might think about it as adding on zeros, but I prefer to think about it as skipping decimals. Every single time I quote add a 0, what I've effectively done is moved my decimal over. So if I was going to multiply this 10 times 10 and show this multiplication statement here, 10 to the power of 2, 10 times 10, I'm going to be moving the decimal place over by 1 0. So 10 times 10, I would move that decimal over and fill in my spot here because I can't just have an empty place value spot. There we go. So that would give me 100, and of course 100 also has a decimal. There it is. I could do that over and over again. So just going backwards here. So here's my 10 again. If I wanted to multiply 10 times 100, so I have 10, I'm multiplying it times 100. That means that I'm adding this much on, or multiplying this many powers on. That's 1, 2, 10, so it's going to be 2 decimal skips. So 1, 2, I would put my decimal here. I'm just going to get rid of this spot right here. And then you can see that every empty place value spot needs to have a 0 in it. And that makes sense, doesn't it? If I take 10 and I multiply it by 100, 2 decimal skips over, here I have my 1000. So this right here is something that can be reversed as well. We know that multiplication and division are inverse operations. That means they are opposites of each other. And when we are multiplying, the decimal keeps skipping to the right. And hopefully you guys remember from class, I mean, I've been teaching for a while, and kids will often forget which way to skip the decimal if they just think in terms of left and right. Oh, I'm multiplying. Do I go to the left or the right? They'll say to me, and I'll just say, guys, like, think about it logically. If you're multiplying, your number should be getting larger. Your decimal needs to skip in the direction that's going to make your number larger. And similarly, if you are dividing, you're going to have to skip your decimal to the left, but if you forget, you can just go which way is going to make my number smaller. So right here, I have the 1,000 with my decimal here. I'm just going to put little markers on here. So this way is multiplying, and this way is going to be division. So I've got my 1,000, and I am going to divide 1,000 by 10. So 10. Dividing 1,000 by 10, that means here is my 1,000 right here. If I divide it by 10, I'm going to be taking one of these off. The decimal is going to have to skip one place value spot because there's 1 0 in the number 10, and I would be able to just do that. So 1,000 divided by 10 is 100. I could do the same thing with other numbers. I could take this 1,000 and divide it by 100. Well, 100's got 2 zeros in it, so 2 powers of 10 is what I'm skipping. 1 decimal. 2 decimals, and that would go right there, and then I would end up with the answer of 10. And that is how you use these powers of 10 to, figure out how many decimals you're skipping. So let's do a couple of practice questions just to make sure that this is really, really clear for you, and I'm going to throw some decimals at you just for the practice sake of it. So we're going to start off with, let's go 25 and 61 hundredths, and I am going to multiply this by 100. So 100 is the same as saying, hopefully you see this, it's the same as saying 10 times 10. In grade 7, you will learn that this is the same as saying 10 squared, 10 to the power of 2, but that's coming up, okay? So knowing that about the number 100, I should be able to go, okay, multiplication, my decimal is going to be skipping to the right, my number's got to get bigger, there's 2 powers of 10 at work here, here's 1 power of 10, here's the other power of 10, that's where my decimal is going to end up, and I'm going to end up with an answer of 2,561. All right, we're going to do, let's take the same number, and instead of multiplying, let's divide it. So let's divide it by 1,000. So hopefully in your head, you're seeing that 1,000, and you're recognizing that 1,000 is the same as saying 10 times 10 times 10. Which, again, when you get into exponents in grade 7 and 8, you will also learn is the same as saying 10 to the power of 3, or 10 cubed, but we don't need to know that at the moment. What I do need to understand is that I've got 3 powers of 10 and action here. I'm dividing, which means I've got to be thinking which way does my decimal go. My number should be getting smaller, so I'm going to head over to the left, and I'm going to go skip it 1, 2, and 3. Oh, okay. So I have this empty spot here. I'm going to have to fill that in. This right here is going to equal decimal 0.2561. And we also talked in class about how anytime there is nothing in the whole column before the decimal, we put a 0 there just to make sure that nobody misses the decimal. And your answer for this question, 25 and 61 hundredths divided by 1,000, is going to be 0.02561. And that is how you divide and multiply by powers of 10. So there'll be some practice questions. Hopefully that makes sense. I'll be in office hour if you need some help. Good luck, guys.